going to do notes for 20.2 today, target 5.7G, which is calculate the pH from the hydronium ion concentration or from the hydroxide ion concentration. So with this, we need to know basically two equations. I'm going to start with the basic one, and that is Kw is equal to the concentration of hydrogen ions times by the concentration of the hydroxide ions. So these brackets right here, they mean concentration, and that concentration is always in moles per liter, which remember we just learned could be represented by a capital M, molality. This is your hydrogen ion. Sometimes they're going to rewrite that as H3O+, because it will attract to a polar molecule. This one right here is your hydronium ion. If you see an H plus or if you see an H3O plus, that's usually representing an acidic solution. And when you see OH minus, that usually means that you are looking at a hydroxide ion. Now your Kw is your ion product constant for water. Again, ion product, here's an ion, and you're multiplying them, and again for water. What is water made up of? If you take H plus and OH minus, you get H2O. Okay, so that's where this is coming from. Now, water is considered to be neutral as long as it is pure, which means if this is pure, you're always going to have equal amounts of H plus and OH minus, and that's why it is equal to a constant. Now that constant is 1.0 times 10 to the negative 14. So it's always going to equal that when you multiply those two together. So if for some reason this number goes up, your H plus concentration, your OH minus concentration would have to go down so that it would always equal this constant. So when we are working with this, we can use concentrations to determine if something is acidic or basic. When you look at this equation, you can also figure out what these would be in a neutral solution. So if we are talking about a neutral solution, your concentration of H plus would equal 1.0 times 10 to the negative 7 molar, and your OH minus concentration would also equal 1.0 times 10 to the negative 7 molar. They would have to be the same. Now if you put these into your calculator and multiply them together, you're going to get the ion product constant. Now, if you have an acidic solution, that's going to mean that your H plus is greater than your OH minus concentration. So that means when we're looking at an actual concentration, if it's going to be acidic, your H plus concentration would have to be greater than 1.0 times 10 to the negative 7. So something bigger than that. So it could be 1.0 times 10 to the negative 5. 1.0 times 10 to the negative 2. Those are examples of concentrations that would be greater than 1.0 times 10 to the negative 7. Now if you have a basic solution, it's going to be the other way. Your H plus concentrations are going to be less than your hydroxide ion concentrations. So when you're looking at a basic solution, your H plus has to be less than 1.0 times 10 to the negative 7. So that would be something like 1.0 times 10 to the negative 8, 1.0 times 10 to the negative 11. These are things that are less than that. Now this concentration, or this equation, can come in handy later. Like if we know the pH of the solution, but they ask us for the concentration of hydroxide ions, we can come back and use this equation. So let's try a sample problem. They could give us, I'm reading a problem just from your book. If the hydroxide ion concentration is, so your OH minus, your hydroxide ion concentration is 1.0 times 10 to the negative third molar, what is the hydrogen ion concentration? And then it asks, is it acidic, basic, or neutral? Acidic, basic, or neutral? Okay. So to find the H plus, you're going to use this equation. Kw is equal to concentration of H plus times by the concentration of OH minus. This is 1.0 times 10 to the negative 14th. We don't know this, and this one is 1.0 times 10 to the negative 7. So to solve, you're going to divide by 10 to the negative 7. Okay. So what is the concentration of H plus? I don't have my calculator, so I'm going to do it the old-fashioned way. 1 divided by 1 is 1. And then when you're dividing, you're going to take negative 14 and you're going to subtract the exponent down here. So that's negative 7. So that'd be a plus. So my answer is 1.0 times 10 to the negative 7 molar. So that is my H plus concentration. Then it asks me, is it acidic, basic, or neutral? Well, 1.0 times 10 to the negative 7 is neutral. Okay. Some other questions they could ask is if you have an H plus concentration of 6.0 times 10 to the negative 10 molar, is that acidic, basic, or neutral? Again, I focus mainly on this number. Negative 10 is less than negative 7. If it's less than, that's a basic solution. Okay, so use those numbers to help you determine what they are. If they were to give you the hydroxide ion concentration, you could use this equation to find the hydrogen ion concentration. All right, from here we're going to move on to a more simpler equation to use. And technically you could just use this equation for all of it, just with a little more work. So next it would be our pH equation. pH is equal to negative log times the negative log of the concentration of H plus ions. Now remember, sometimes they will use hydroxide. The hydroxide symbol means the same thing. Now you've got to be careful with this. pH is going to give us, the number will tell us if it's acidic, basic, or neutral. No, those were given in the last notes. But when you're using this equation, make sure that you realize this is a negative 1 that is being multiplied by your answer. So what happens is when you do the log of this number, it's going to come out to be negative, and then you have to multiply it by negative 1. Just as a quick reminder, if you get a pH that is greater than 7, it's basic. A pH less than 7 is acidic, and a pH that is equal to 7 is neutral. Okay, so this is going to be important because if you're using this equation, it's to tell if something's acidic, basic, or neutral. And this is where I said, when we're up here, when we have a number, it's actually easier sometimes to use the pH equation to figure this out. So let's use this. Let's go up to the very, very top. Now here, I'll just write it down here. If we say that H plus is equal to 1.0 times 10 to the negative 7 molar, and you want to know what the pH is, you are going to go pH is equal to negative 1 times by the log of 1.0 times 10 to the negative 7. Okay. How do you do this? You need your calculator. Okay, you have to have your calculator. I have my calculator. For some of you, you'll have to press your log button first. For me, I press it second. So I'm going to put in my concentration. So I'm going to go 1.0, my special button, EXP, negative 7, and then I'm going to hit my log button. See where it says log, L-O-G, log. And it gives me an answer. Oops, let me try that again. I'm on an angle, so it doesn't want to work. All right, and so it gave me negative 7. So I now have pH is equal to negative 1 times by negative 7, which gives me a pH of 7. So what does that tell me? It's a neutral solution. Okay, it is neutral. let's try another one. We'll just try variations. If my concentration of hydrogen ion is 1.0 times 10 to the negative 10 molar, what is my pH? Okay. So again, pH is equal to negative log the concentration of 1.0 times 10 to the negative 10. So again, go back to my calculator. 1.0 EE to the negative 10. I don't know if you can see that. Then hit my log button. And it gives me negative 10. Negative 10 times negative 1 is 10. So I have a pH of 10. So this is basic. That's all you do. Now, I don't know if you noticed, for this one, we have a pH of 10. When I had the concentration of H plus is equal to 1.0 times 10 to the negative 7 molar, I got that the pH was 7. Look, right here. So, right off the top of my head, if I know that my concentration of H plus is 1.0 times 10 to the negative 8 molar, I can tell you my pH is 8. So a little bit of a shortcut, but this only works if your coefficient is 1. So keep that in mind. Only works if your coefficient is 1. Let's try the other problem that we just had. We had H plus is equal to 6.0 times 10 to the negative 10 molar. This will not give me a pH of 10 because this is not a 1. It is a 6. So I have to put it into my equation. 6.0 times 10 to the negative 10. So, again, calculator makes it very, very easy. 6.0 EE negative 10, and then hit my log button. And it gives me a negative 9.22. So, times that by negative 1, that gives me a pH of 9.22. I'm going to give 2 decimal places because I have 2 significant digits here. So my pH is 9.22, which makes this a basic solution. You can also go in the reverse. If they tell me that my pH is equal to 2, I know, since this is exactly 2, that my hydrogen ion concentration would be 1.0 times 10 to the negative 2 molar. Or if my pH is equal to 5, then my hydrogen ion concentration is equal to 1.0 times 10 to the negative 5 molar. Now, they're not all this easy because my pH doesn't always come out to an exact number. What if I have a pH that is equal to 8.27? What is my hydrogen ion concentration? Okay. With this, I'm going to have to go backwards. So I've got my pH equation. I've got 8.27 is equal to negative 1 times by the log of X. I don't know what that is, what my hydrogen ion concentration is, so it becomes X. So first thing I got to do is move this over here. So if you divide both sides by negative 1, you're going to get negative 8.27 is equal to log of X. Okay, log of X. How do you get rid of log? Well, you have to use the second button or the inverse button. You have to do the inverse of that, like inverse sine or inverse cosine, or the opposite of your square root. So on my calculator, what I'm going to have to do is, if you can see this, I'm going to go 8.27 and make it a negative. So a negative 8.27. I have to hit my inverse button, INV, inverse, and then hit log. And it gives me my answer. Now notice it's not in scientific notation, so next I'm going to turn it into scientific notation so that I can see my decimals. Okay. So this is my actual number, 5.37 times 10 to the negative 9th, sorry. So my X, which is my hydrogen ion concentration, comes out to be 5.37 times 10 to the negative 9th molar. Remember, it's a concentration, you need a unit.